Hello. Today we are going to begin our lesson on plant identification. You hopefully have already watched the video about plant taxonomy and classification of living things. And today we're going to focus more on the plant key and how it works. And so hopefully you have one of these. If not, you need to get one ASAP, and then you might have to watch the video again. This is the field guide to the trees and shrubs of the Southern Appalachians. Okay. So, we're just really dealing with woody plants, and the way that this key works is primarily based upon leaves and leaf structures. But there are other questions that the key or keys can ask you. One thing to understand about the way that a plant key works, or any sort of taxonomic key, is it's going to ask you a series of two questions typically. Only one of those questions fits your specimen. And so depending on what choice you make, as we'll see when we do the exercise, depending upon what choice you make, it will take you somewhere else in the key. Okay, so it's basically using the process of elimination. And so the way that it works is, you have this plant here and you're like, what in the world is this plant? Well, somewhere in the book is the name of this plant. And you can use the process of elimination to eliminate all of the things that the plant is not. And ultimately you end up, at least theoretically, at what the plant is. Okay, so that's the goal. Today, we're just trying to learn the basics. And then as we progress, you're going to be responsible for 5 species a week for the next 6 weeks. And that'll be what you'll be using for your herbariums. So let's get started. One of the main characteristics that we deal with ends up being leaf structures. Okay, and so let me share my screen real quick. And then open up this little board here. I'm going to talk about some things here. One of the things kind of the first most obvious thing is going to be whether or not the leaves are opposite or alternate on the twig. And so if you have a twig, and the leaves come off of that twig in a fashion like this. There's one leaf there and one leaf there. Sorry, it's very difficult to draw on this thing. Then we say that the leaves are opposite. In other words, they're coming off one another opposite. Compare that to alternate, where you have that twig and the leaves come off and they alternate back and forth. Now, this is opposite versus alternate is very cool because it immediately allows you to put any plant in one of two groups, right? So if it's opposite, we eliminate all the alternate things and vice versa. So this is one of the characteristics that's very useful in our discussion. And we'll look at lots of examples of these different traits. Okay, so that's one. The leaf itself can be simple or compound. And this can be a little bit tricky to figure out what a leaf is, in fact, but the way that you can figure out what a leaf is you find a growing shoot or stem, and if the leaf, whatever's coming off of that growing shoot or stem is a leaf. And so if the leaf has a single blade like this, then we would say that this plant has simple leaves. But it could just as easily have compound leaves where you have the little petiole, that's the stem of the leaf. And what if we have something like this? So that would be an example of a compound leaf. By definition, a compound leaf is a leaf which consists of two or more leaflets. In this case, we have 1, 2, 3, 4, 5 leaflets. You know, the trick is to look at this and understand that this is not a leaf, this is a part of a leaf, and that this entire structure is, in fact, the leaf. And again, the way you can do that is by finding a twig, a growing shoot, and breaking off whatever's attached to it. So simple and compound is also a very useful characteristic. Leaves can also be lobed or unlobed. And so you could imagine, you know, an unlobed leaf, lobed being broken up into segments. It's a little different from compound. And so let's look at unlobed, something like this, versus lobed. And you've all seen, obviously, this type of thing in nature. We had something like that, we could say the leaf is lobed. Often its veins will run into the lobes, okay? So here's the thing, the difference between a compound leaf and a simple leaf that's lobed is if you have to tear through the tissue to make a leaflet, then it's not a leaflet. So in other words, in order to separate this, you're literally tearing through tissue. Here, you don't have to really tear through any tissue. You can just pluck these off individually, okay? So unlobed and lobed, simple and compound. We're gonna look at examples of these. There's one other one that we'll do real quick, and then we'll look at some actual leaves. The other one has to do with the veins of the leaf or the lobes of a compound leaf. It can go either way. You can have a leaf that is simple, like this. You can have a leaf that is palmately compound. And palmately compound, think about like the palm of your hand. It's got these pieces coming off like this. And you know, each one of these might be a leaflet, kind of like this. Sorry, it's not very good art, but you get the idea, right? The thing about palmate is all of the major lobes or veins, if it's a lobed leaf, meet at a central point like this. And we're going to see examples of all this. It's just helpful to draw it out before we do examples, or before we actually look at it. And then you can also have pinnately compound. And in pinnately compound, you have a central vein, and then you have the leaflets coming off kind of opposite one another. Sometimes there'll be one on the end, but there's not always. Kind of like this. And you could count the number of pinnae or leaflets if you wanted. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9 leaflets, including the end leaflet. So palmately compound versus pinnately compound. Now the thing is, you can take a simple leaf and you can apply these same words like pinnate and palmate to the veins of the leaf. So here's a simple leaf, and if I draw the veins like this, we could say that this has pinnate veins. Compare that to a leaf that has palmate veins like this. And it could be a lobed leaf. So this is not a compound leaf, it's just a lobed leaf. But you can see that it's got a similar vein structure to this palmately compound leaf. Okay. So point is, pinnate and palmate can apply to compound leaves or to the veins of simple leaves, either one. Okay. So now let's stop and let's just look at some, oh my goodness, I don't know what I just did. Let's just stop for a second and let's look at some examples of these. Make sure I'm recording. I would sure hate to get through the video and not have any of it recorded. Okay, so here we go. Let's look at this twig right here. Okay, and I think you can see that pretty well. And actually, this one's a little confusing. I'm sorry. That's not a very good one. Let's look at this twig, okay? And it's always good to look at several leaves, not just one. But if I asked you, okay, is it opposite or alternate? Well, you can see these leaves are coming off opposite one another off of the twig. See that? And then there's the second set and the third set. So they come in pairs, okay? And so we would say that this is an opposite, twig has opposite leaves. Okay. Now, take a look at this one. Here we have a different scenario. We have alternating leaves. Okay, so opposite versus alternate. It's a good characteristic. It's really one of the first things that the key is going to ask you. Okay, so there's that. What about venation? Well, and what about simple and compound? Let's look at this twig. Okay, so I've got a growing shoot here, and I break off a leaf off of the growing shoot. And you can see that this one leaf consists of a single blade, okay? And so I would say this is a simple leaf. Now, you might get confused and look at this and think it's a giant compound leaf, but keep in mind I broke this off of what is a growing shoot, and so this is actually a simple leaf plant. What about the venation? Remember we talked about palmate and pinnate. And if you look closely, you can see this is a really great example of palmately veined, right? All of the major veins are coming off of this central point right here and radiating outward, kind of like the palm of your hand, like fingers, okay? So that's a good one. And, granted, sometimes things can be a little ambiguous, and you're looking at it and trying to really decipher it or figure it out, okay? But usually it's not too hard to tell. Now let's look at the veins of this leaf. And let's ask ourselves, first of all, is it simple or compound? Well, here's a growing shoot. I break a leaf off. This one's prickly, gotta be careful. I break a leaf off and you can see it's a simple leaf, okay? And I'm hoping you can see the veins. There's a central vein there, and then there's a bunch of smaller veins radiating out. So this is a good example of pinnate veination. Now, if we look at compound leaves, great example of palmately compound leaf. This is Virginia creeper. You've seen it everywhere. Look at this one leaf. So here again, here's a growing shoot. I break off a leaf, right? And now you can see this is a compound leaf. It consists of 1, 2, 3, 4, 5 leaflets, right? It's palmately compound, right? Okay. Now look at this one. This one is, here's the growing shoot, and there's actually a bunch of fruit on the end of this growing shoot. But, oh, there's some thunder. Take a look. This one has opposite leaves, right? If I break a leaf off of the growing shoot, you can see that the leaves are compound. So it's opposite and compound, right? And you could count the leaflets, I suppose, if you wanted. Okay. Now, this is a really good example of pinnately compound leaf, right? Okay. So these are some of the most basic things, and you're developing a vocabulary, okay? Some other things about leaves that we need to be clear on. Leaves can be evergreen or deciduous. Let's take a second to define this because it's very important. There's this word deciduous. versus evergreen. Evergreen, you know about evergreen, right? Evergreen means that the plant never loses all of its leaves. It might lose some of its leaves in the fall, but there's always going to be some leaves present on the tree. Deciduous literally means to drop one's leaves. And so we have many types of deciduous trees here. Many of the specimens that I've been showing you are deciduous. Okay. Now here's the thing, in the wintertime, it's very obvious, right? If it's deciduous, it doesn't have any leaves in the winter. If it's evergreen, it does. But what about in the summer? You know, what are some ways that you can tell deciduous from evergreen? So we're going to look at that. Another thing to look at, are the leaves needle-like or scale-like? It would be good for you to write these down. I'll show you in the book where there's some information about this. These are two very useful ways to group plants. Is it deciduous or evergreen? Are the leaves needle-like or scale-like? So let's talk a little bit about how in the summer during the growing season you might be able to tell these two apart. And then we can look at the key and see how it's arranged and all that. Okay, so deciduous versus evergreen. Typically speaking, evergreen leaves are a giveaway because they're really shiny, is one thing about them. And the blade is very thick. And so if you think about the thickness of a leaf, it doesn't seem very thick, but compared to a deciduous leaf, it's going to be much thicker. Okay. The idea is if you're not going to drop your leaves, you might as well make a really good leaf, you know. They typically have a waxy cuticle to protect them from water loss. Here we can see some English ivy. It's also an evergreen. The leaves are very thick in the English ivy. They're not really super shiny. About the veination, I would call that palmately veined, right? It's lobed. It's a simple lobed leaf that's palmately veined. This is a common shrub planted around here. It's not native, but if we look at it, let's take a look. Oh, there's some mealy bugs on there, that white. Is it opposite or alternate? Well, there's a couple of leaves and they're opposite. Is it simple or compound? Well, break a leaf off. It's a single blade. It's a simple leaf. Okay. And then you can see how shiny and thick the leaf is. So another good example of an evergreen. We can look at this specimen for a second. And you can see these leaves, they do look a little shiny, but they're very thin. You can see how they're kind of wrinkled and thin. And so that's going to be a deciduous one. If you're in doubt, you know, you have to make a choice. You have to make a calculated guess, you might say. What about needle-like and scale-like leaves? Many, many plants that all turn out to be evergreen plants, just about, there are a few exceptions, have needle-like leaves, which you're familiar with. This is a pine tree, right? And in a pine, the needles are bound in fascicles or bundles. And so I can pull a bundle of leaves off of this, and I could actually count them. And there's 1, 2, 3, 4, 5 needles in a bundle. You can see how they are bundled together there. Okay, so this would be an example of needle-like. Needle-like leaves may be in fascicles, they may be bundled together or not. They could be borne singly on the twig. And then scale-like leaves, you know, if you can zoom in on that, you can see the leaves are tiny and they're like little scales. And so this is a good example of scale-like. Here's another one. You've probably seen these plants growing. This is juniperus or cedar. These are both actually cedar species. Okay? So there's actually a whole key in the book that deals with needle-like and scale-like leaf plants. One thing that it's hard for me to demonstrate because you're not in front of me, but if you were, I would be passing twigs around, is are they aromatic? And aromatic means, do they have a distinctive odor? Aromatic is not, you know, everything has a smell, y'all. It's not, does it have a smell? It's does it have a strong distinctive odor? It doesn't have to smell good or bad. It just has to be strong and distinctive. The way that we can tell if something is aromatic is by scratching and sniffing the twig. And so what I mean by that is, if you just sniff it like this, it's probably not going to smell. But the way that you can get the aromaticity is by scratching the bark away from the twig and then giving it a sniff. And you'll know very quickly. It's so interesting, depending upon habitat and environmental conditions, plants, the leaves might look different, the bark could look different. The smell is always the same. If you can learn the aromatic plants by their smell, you're going to do really well and always be able to recognize those just by scratch and sniff. Okay. The margins of the leaves might be important as a characteristic. And there are basically two possibilities. One is called dentate. And what does that sound like? Dentate sounds like your teeth, right? And you can see the little teeth, the leaf is toothed, and I'll draw this in a second. Okay. Might be able to see it better from the back side. Yeah, I think you can see that now. So there's dentate, and then there's leaves that the margin is what we call entire. And in an entire margin, the edge right here of the leaf is not toothed. It's not dentate. Entire means not dentate. Let's look at this leaf. This leaf is interesting. Has palmate venation. It's palmately lobed. It is a lobed leaf. It's a simple lobed leaf. It's also toothed. So it has lots of characteristics, right? So it's dentate, it's lobed, and it has palmate venation. All of these words are running together. You might have to watch the video a couple of times, okay? So that's good. One other thing that the key may ask you, is the plant self-supporting? In other words, is it able to stand on its own? Or maybe it's not. Maybe it's a vine. It might say climbing or scrambling, is it climbing up other vegetation? Vines can be a little tricky, but not usually. I mean, you can see here we have two different plants. One of the plants is holding on to the other. The one that I'm holding in my hand has wrapped itself around this other plant. And the way that it's done that is by using these little tendrils. You see the tendrils? Tendrils are modified leaves, and it's using these little tendrils to clasp around the stem. You can see that right there, okay? And this allows it to grow, okay, to grow up another plant. So that's, another characteristic. Let's just cut back real quick to the, sorry, I know there's glare on my glasses and I probably look like a cartoon character, but these are the only glasses I can see the screen with. I apologize if it's goofy looking. Let me just open up I need to share my screen real quick. And I just want to make sure you got the margin thing. I should have done this earlier. I forgot. There's this word aromatic. And again, this word aromatic means having a strong, distinctive odor. Margin of the leaf, entire. And again, when you're talking about this, you're looking at the edge of the leaf versus dentate. And you could imagine a dentate leaf. It's got all these little teeth. And you have to be careful, they may be obvious and they may not be obvious. Okay. Believe it or not, y'all, that is literally most of the characteristics that we're going to need in this class in order to use the key, okay? So now let's talk a little bit about the key. And Um, the key, there's an intro. You should read the introduction, and it talks about terminology. It talks about all the different species we have in the southern Appalachians and the mountains, and why, and that's interesting. A little bit about structures of woody plants, and then right here, and if you, I'll give you a second if you want to break this book out and turn to page 6 for a second. Okay. You can see some different characteristics on page 6 of leaf morphology, right? You can see what we talked about, alternate and opposite, and simple and compound, twice compound, where the leaflets have leaflets. I would draw your attention to this one. It says world, W-H-O-R-L-E-D. And a world is kind of a type of opposite where there's more than 2 leaves coming out in the same spot on the stem. Here they show 3, there could be 4, 5, or 6, all coming out of the same spot. Okay, you can see pinnately and palmately compound there. And then I'm just going to tell you, as far as the shapes of the leaves go, this is the short list of the shapes of the leaves on page 7. And I wouldn't expect you to memorize those. Leaf bases, leaf margins, leaf apex. You know, if it asks you, is the leaf oblanceolate or obovate? Well, I suppose if you were really into it, you could memorize all those, or you can just always refer to the chart. Okay. So let's take a look at the way that this key is set up. Let's go ahead and turn to page 23, because really it's not just one key, it's a series of keys, okay? And if you look on page 23, there's key 1, okay? And key 1 says plants with needle-like or scale-like leaves, okay? So what I will draw your attention to, and we're actually going to use this key. We're going to key, and this is going to be hard for you to see, but I'll walk you through it. We're going to try to key this out because this plant does have needle-like or scale-like leaves, okay? Now, if you were trying to key out this plant, it obviously doesn't have needle-like or scale-like leaves, okay? Okay, so actually, I said we were going to do that one. Let's do this one because it's a little easier to see. This one has needle-like leaves, not scale-like leaves. The way the key works, there's always a number and a number prime, and you're always going to start at 1 and 1 prime. Okay, prime is the little dash beside the number. Okay, and so find 1 and 1 prime. Those are your first 2 questions. And so if we're doing this twig right here, this plant, it says foliage leaves needle-like, more than 8 millimeters long, or foliage leaves scale-like, less than 5 millimeters long. Okay, so now here's the thing. Don't just think you know how long a millimeter is. There's a ruler, actually, look. There's a ruler in the back of the book right here on the back page. Probably, it's hard to see, but you can find the ruler, or you can buy a little ruler. Just go ahead and measure, but clearly, you know, these needles are a great deal more than 8 millimeters long. 8 millimeters is about a centimeter, a little less. Okay, so these are longer than that. Now, check it out. If you would have chosen 1, which we did, that takes you to 2 in the key. If you chose 1 prime, where does it take you? Well, you go. It's in outline form, and so from 1 prime, if we said the foliage leaves were scale-like, we would be at 5. But since we said foliage leaves needle-like, we are in fact at 2 and 2 prime. Okay, so 2 and 2 prime. Now we read those 2 questions and we make another decision. 2 says needles and fascicles of 2 to 5, each fascicle enclosed at the base in a papery sheath, or 2 prime says needles borne singly on the twigs. Well, let's look. Here's our twig. We break off, and we see that these are in fact in bundles, which we saw earlier, right? You can see that there are in fact 5. There's a little bundle. In the little bundle, it's called a fascicle. And this one has 1, 2, 3, 4, 5 needles in its little bundle. Okay, so look where that brings us out. It says pinus or pine. So we chose 1 and then we chose 2. If we would have chosen 2 prime, if we would have said the needles were born singly on the twigs, we would have been at 3 and we wouldn't have been quite finished. Okay, so it says pine, pinus, page 95. So if we go to page 95, now we've come out at what we call the genus, which you learned about in the previous video. Okay, and now when we get to page 95, there's another key that brings you to the actual species in this case. And so now we're in the Pinus genus, and the first 2 questions says leaves and fascicles of 5 or leaves and fascicles of 2 or 3. Well, we have 5, and so what does that come out to? P. strobus, right? Or Pinus strobus. And now here's what you get on page 95. You can see Pinus strobus is at the bottom of the page. It says a large tree, bark on mature trunks deeply and closely furrowed, so it gives you a description. And then if you turn the page again, you can see they have a picture of the different pine species, and white pine happens to be the one at the top there, okay? So this is the basis of how the key works. Now, there are about 600 species in this book. Using the process of elimination, we were able to look at our twig and realize what species was, okay? And I'm going to let you in on a little secret. This is a type of white pine. It's not our native white pine. This is an ornamental, and the needles are much shorter than white pine, but it does key out to white pine in our key. It's not actually in the key. I just didn't want you to be confused, okay? So let's look at how the keys are set up. This is key 1. Turn the page. And on page 24, it says summer keys, and we're in the summer still, so we're going to be using these keys. Now look at key 2, plants with opposite or world simple leaves. Okay, let's pick another plant to look at. Let's try keying out this one. I don't know that I've ever keyed it out. It's got these fruits on it, which are cool. It's got, let's just look at it for a second. It has opposite leaves. Right? Are they simple or compound? The leaves are compound. Are they pinnate or palmately compound? They're pinnately compound. So we have an opposite leaved plant with compound leaves. Okay. So let's see if we can find what key we want to be in, because I'm going to tell you one of the biggest mistakes you'll make is you're trying to key the plant out in the wrong key. It doesn't work. So key 2 says, well, let's go back to key 1. Key 1 says plants with needle-like or scale-like leaves. No, it's not that. Key 2 says plants with opposite or world simple leaves. Well, this does have opposite leaves, but they're not simple. So we have to get through that key. Now, the next one says plants with opposite or world compound leaves. Well, look at this twig and tell yourself this plant has opposite compound leaves. Okay? So now we're at least in the right key, which is good. Now let's try keying it out. 1 and 1 prime. Leaves palmately compound, leaflets 5 to 7, or leaves pinnately compound, arranged in 2 rows along the petiole. Well, we've already learned this, and we see here that this leaf is pinnately compound. Okay? So now that takes us to 2, because we did 1 prime, so now we're at 2. Okay. Now, there's always going to be a 2 prime, and you have to realize it could be on the next page, literally. You might have to turn the page to find the 2 prime. It's not in this case, but there will always be a number and a number prime. Always find the number prime. This is another little problem that we have sometimes using the key. So now this one says, stems climbing, sprawling, or trailing, vines. 2 prime says stems self-supporting, trees and shrubs. Now, we talked a little bit about this before. This thing looks pretty self-supporting to me. I don't see any tendrils. It doesn't really look like a vine per se. Okay. Sometimes this can be a little tricky, but usually it's obvious. Okay. So where does that take us? We chose 2 prime, stems self-supporting, trees and shrubs. So now we are at number 5. Okay. And number 5 says, petiole bases of opposing leaves meet around the twig connected by a transverse line or ridge, or petiole bases of opposing leaves not meeting or connecting by a transverse line or ridge. So it wants to know, what it's asking you is, and this is going to be hard for you to see, and you're going to kind of have to take my word for it, I think. I'll try to zoom in on it. You can actually see it. If you look right there, where these two leaves come together, they're actually connected. The petiole is flared out, and it actually touches the other side of the petiole of the other leaf. And so this is something you would be able to see much more clearly if you were looking at it in real life, or we were looking at it together. Okay, so that takes us then to 6 and 6 prime. Now, again, if we would have chose 5 prime, we would be at 7, but we didn't. We chose 5. Okay. Now it says leaflets 3 to 5 or leaflets 5 to 11. Well, check it out. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So it's not 3 to 5. It is, in fact, 5 to 11. Sharply and regularly toothed. That might be a little hard to see, but they are. Okay. Twigs greenish, brown or reddish brown to gray, and not glaucous. Glaucous is white and waxy. Okay. So this comes out to elder sambucus. And so now it says go to page 366. And so we go to 366, and hopefully we keyed it out right. We go to page 366, and it says sambucus, elder, and then there's actually a key there. There's only 2 species, and it talks about the pith. And the pith is actually the very center of the twig. And so this is one of the characteristics I probably should have mentioned, because now it's come up. But the way that you can tell the pith is by taking a knife or a razor blade is the easiest way, and shaving it. But I have these clippers here, and I can just clip down the middle. And I'm pretty sure I know what the species is, and the pith is going to be white. You can see it's pure white. And this species is Sambucus canadensis, which is black elderberry or American elderberry. Okay, and you can see the elderberry fruits. They are edible when they're ripe. If you eat too much, you might get the runs. Okay, team, this is how the key works. Now, let's go back to the different keys, because I do want to point out we were just in key number on page 31 in key number 3, plants with opposite or row compound leaves. Let's pass through that. Now we get to key 4. Key 4 is the largest key in the book. It's plants with alternate simple leaves. And it turns out that there are more alternate simple leaved things than anything else in our flora. Okay, so many times, you know, you're going to be in this key. Okay, here's an example: alternate simple leaves, right? Okay. Here's another example: alternate simple leaves. Okay, maybe we'll keep this one out, and we can look at how it works. Now, in this key, it requires a little explanation. You'll see it says index to main divisions of the key. This is kind of like a cheater key here at the beginning. And the way that it works is you start reading at the top, and if it fits your specimen, it allows you to jump to that number and that page. That's the key step number in the page. And again, we're on page 32 in key number 4, plants with alternate simple leaves. Now, here's the thing. If you pass the step that fits and go further down, you may have actually passed your specimen. So what I'm going to ask is you don't use the cheater key yet. We're going to start at 1, okay, and 1 prime. And heck, we might as well try and key this sucker out. See what happens. Okay. So one says plants with stems climbing or scrambling, vines, plants not climbing or scrambling, not vines. This is not climbing or scrambling. It's a tree, small tree. Okay. Leaves small, 5 to 8 millimeters, or leaves larger. Clearly has larger leaves. Okay. Oh, I made a mistake. I apologize. See, I got ahead of myself, and I skipped key step 11, right? So I chose plants with stems not climbing or scrambling, not vines. Key step 11 says stems low, creeping, prostrate, or mat forming, often scarcely woody. 11 prime is on the next page, and it says mostly erect or ascending. What they're getting at is some things creep along the ground. This does not creep along the ground. This is erect or ascending. It's not low or sprawling or reclining. Trees and shrubs is what we're talking about. Now 16 says leaves palmately veined. Be sure to read 16 prime, even though you think you know the answer. We go to 16 prime, it's actually on the next page. 16 prime says leaves pinnately veined. So I'm gonna let you look at this leaf and you tell me, is that palmate or pinnate? That is palmately veined, right? So we're getting closer. Now it says plants armed with thorns or prickles. 17 prime says plants not armed. Okay. And there's no thorns or prickles. They're pretty obvious. When something has thorns, you know what thorns look like. This does not have thorns. That takes us to 20 and 20 prime. Plant, this is the sap milky. And so the way, some plants produce latex. You've seen this in dandelions probably. And the way that you can do that is by breaking a stem and seeing if some kind of milk oozes out. So I break this stem and I'm not seeing any kind of milky substance. So I'm going to go to 20 prime. Plant's not milky. Okay. This next step is a little bit tricky. It asks you about the base of the petiole. The petiole is where the twig attaches to the stem. Okay. And it wants to know, is the base of the petiole hollow? And this one is not hollow. This keys you out to sycamore, and this is not a sycamore. So the 22 prime says base of petiole is not hollow. Okay. Takes us to 23. Leaves with 2 or more large veins branching short distance above the point where the petiole joins the blade. Leaves entire or 2 or 3 lobed. Well, this plant is not lobed, okay? And this says leaves with 3 to 5 nearly equal large veins. And you can see this one has 3 to 5 nearly equal large veins, okay? 24, boy, this is a lot of work, isn't it? We're getting close though. We're getting close. 24, leaves covered with woolly hairs, or 24 prime, leaves not densely covered. No. 26, leaves or most of them lobed, or 26 prime, leaves not lobed. Check it out. No lobing in the leaf, right? Now, this is an interesting characteristic that they're going to ask you. It says, it asks you now about the petiole. The petiole is the stem of the leaf. It's the stem that attaches the leaf to the twig. And I've broken this leaf off. And it says petioles less than 2 centimeters or petioles more than 2 centimeters long. This is more than 2 centimeters. I can tell, but I'm going to measure it just to be accurate. And when I measure this, I'm getting a good solid 4 centimeters in this petiole. Okay. And now it says petiole is more than 2 centimeters long. This is 31 prime. Let's look at 33. Leaves entire, heart-shaped or nearly circular. And look how beautiful that is. 32 prime says leaves unequal at the base, one side distinctively larger than the other. And I'm sorry, no. It says leaves toothed. So are the margins entire, heart-shaped, or nearly circular, or are the leaves toothed? This leaf is not toothed. The margin is entire. and it is in fact heart-shaped. So this keys out to what? Cercus canadensis, which is redbud. Okay, and so if we in this case, the key took us right to the species. There's no more keying, but we go to page 230, and you can see a picture of the redbud. Figure, well, there's a description of it, a small tree or shrub, and then figure 85 is a picture right there. And it looks actually pretty good, doesn't it? Okay, so now, I know this is a lot of information, but you now know enough to use this key to identify plants, believe it or not. We've keyed out 3 now. We keyed out one that had evergreen needle-like or scale-like leaves, which was the white pine. We keyed out elder, which has opposite compound leaves. And then we just recently keyed out the alternate simple leaf. Okay. The only other key in the book is alternate compound leaf key. And then I will point out there are winter keys in here as well. So be careful. Make sure you're in the summer keys and not the winter keys as you use your book. You start out with your twig. You write down some of the basic characteristics, opposite, alternate, simple, compound, etc. You find the key you need to be in. You use the process of elimination, following the number and the number prime and making your decisions along the way. Okay, so what I would like for you to do is to find some twigs and start practicing, because this is what you're going to be asked to do each week. Each week we're going to you're going to be keying plants out, and you're going to be building onto your herbarium. I'm going to talk a lot more about the herbariums very soon. You don't actually have to use necessarily the twigs that you key out for your herbarium, but you do need to submit 5 twigs each week to me, and we'll talk about how you're going to do that. And as long as you do that, you'll get your credit for that week. Okay. And then the herbariums are turned in at the end. Okay. So I know that's a lot of info. Okay, so let's, the last thing we're going to do is talk a little bit about the information that you need to provide for each of the 5 species that you're going to gather and key out each week. And this is going to be at your own pace. You can do it anytime. You know, you can do it on Monday, or you can do it on Friday, or you could do it on Sunday. It doesn't really matter. Okay. But let's talk a little bit about the characteristics that I need from you for each specimen. This is what you're going to tell me, and you might want to write this down. Okay. But I need to know, what key was it? In other words, is it the needle-like or scale-like? Is it the opposite, alternate, etc.? You're going to tell me, is it opposite or alternate? Each specimen. And the best way to do this is to number your specimens starting at 1. So the first week you'll have specimen 1, 2, 3, 4, and 5, and then 6, 7, 8, 9, 10, and that's how you're going to keep track of them. And of course, you'll have the name in the end. Okay. Is the leaf simple or compound? Is it evergreen or deciduous? Is it pinnate or palmate? And this can be the veins if it's not lobed, or it can be the lobes if it is lobed, pinnately lobed, or veined, palmately lobed, or veined. Okay. Are the margins entire or dentate? Is it aromatic? Um, and that is a pretty good lips. The one last one, is it lobed or unlobed? If it's a simple leaf. If it's a compound leaf, then it doesn't really apply. So for each plant that you key out, of which you're going to do 5 each week, you're going to submit this information. What you're going to do is you're going to build some kind of a PowerPoint. And in the PowerPoint, you're going to, for each plant, you're going to take a picture of the plant. You can take a picture with your phone, however you want to do it. If you do not have a phone or any way to take a picture, please let me know and we'll figure something out. Okay. And then you're going to make a label. And the label is going to have the following information. It's going to have, believe it or not, the county and state that you collected the plant in. And since we can't really even travel to most countries right now, I'm assuming it's the United States. So, you know, maybe you live in Madison County, so you put, and you got it there, so you put Madison County, North Carolina. Okay. Collected by, well, if it's you, then put your name. The date that you collected it is very important. The date is important because the date tells us how mature the plant was at that given date at a given location. Okay. The species name, remember that includes the genus and the epithet, right? It's a 2 words. It's 2 words is a species, right? We talked about that in the other video. And then the family, we really are big on families in plant taxonomy. We want to know what family is it in. It's in the rose family, the Rosaceae, or the, you know, the Rubaceae, or whatever family it's in. You can look that information up once you know the species. It's easy enough to find the family. Okay. And then a brief description of not the plant, because you're going to give me this information as well, a brief description of the habitat. For example, weedy roadside. Don't get run over while you're botanizing on the side of the road. Okay, or rich hardwood forest or pasture or whatever. It's just a brief description of where you found the plant. Okay. Each week, you're going to do 5 plants. It's not that big of a deal, I promise. And then you're going to put all this information and you're going to dump it into a PowerPoint. And so if we do that for 5 weeks, that's going to give you 25 species. And you're going to then take those 25 species. That's what you're going to turn into me as a presentation. You're going to email me that information. Okay. And just be aware, you're going to have to do it in some format that you're able to do a label, and also that you're able to email it. So PowerPoint or the free PowerPoint program that that Google offers will be fine. You can, you know, do it as a Google PowerPoint, and that's easy to share with me. Okay. So hopefully this is very clear and you understand what we're doing. And if you have questions, you can always email me. Remember, I do have virtual office hours. You can check in there. If you know, here's the thing. You may key it out wrong. You may have the wrong species. And if you have the wrong species, well, that's okay. I will call you out. But if you're in doubt, then send me a picture and be like, is this the right species? Only if you're in doubt, though. I would really rather not get, you know, 75 plants a week to have to confirm. Okay, so do the best you can. As you probably all are aware, there are apps on phones. Please go through the exercise of not using an app on the phone to tell you what the plant is. It's probably not going to be correct anyway. Use the key. Learn how to use the key. It's important. Okay. If you use the key and you come out to Acer rubrum, red maple, and then you want to try the app and see how good the app is, well, go for it. But please refrain from using the app for your identification purposes. We really want to use the key. Okay, it's a very good tool. Now, one last word of advice. The idea of what a species is, well, as we talked about, nobody really knows for sure, and there's lots of variables. And so I've had students literally they're in tears. They're like, I don't know. It's either that one or that one. I can't decide. I don't know. Just pick one and move on. It's not worth stressing over. Okay, so take it with a grain of salt. It's taxonomy. That's my take-home message to you. All right, I hope you've enjoyed the lesson. I think some of it might not be super clear, but it will become more clear as you work in the key. If you have questions, holler at me. All right, take care.